Welcome. Today we'll find all rational zeros of the polynomial x cubed plus 3x squared minus 4 using the rational root theorem and synthetic division. The rational root theorem states that if a polynomial has integer coefficients, then any rational zero can be written as plus or minus p over q, where p is a factor of the constant term and q is a factor of the leading coefficient. Let's find our possible values. Therefore, our possible rational zeros are plus or minus 1, plus or minus 2, and plus or minus 4. Let's list these out and test them using synthetic division. Let's start with synthetic division using x equals 1. Remember, in synthetic division, we bring down the first coefficient, multiply by our test value, and add to the next coefficient. When we get a remainder of 0, we've found a zero of the polynomial. X equals 1 is indeed a zero. This means x minus 1 is a factor of our polynomial. Now that we've found one factor, we can divide our original polynomial by x minus 1 to get the quadratic factor. This gives us x squared plus 4x plus 4. The quadratic factor is a perfect square trinomial that equals x plus 2 squared. This means x equals negative 2 is a double zero of our polynomial. Let's verify our solution by graphing the polynomial. Notice how the graph crosses the x-axis at x equals 1 and touches the x-axis at x equals negative 2, confirming our double zero. In conclusion, we found that this polynomial has three zeros x equals 1, and x equals negative 2, which is a double zero. We found these using the rational root theorem and synthetic division, and verified our answer by graphing.